Welcome students. Today we will see chapter number 1, Rotational Dynamics, part 1. Kinematics, study of object in motion without considering force which is responsible for motion. For example, distance, displacement, speed. Dynamics, study of object in motion with considering force which is responsible for motion. For example, centripetal force, centrifugal force. Circular motion. Motion of an object along the circumference of the circle is called circular motion. For example, motion of the tip of the blade of fan, motion of the planet around the earth. Rotational dynamics. When a rigid body moves in such a way that all the particles of the body move along circles, the motion of body is called rotational motion. Characteristics of circular motion. First, it is accelerated motion. Means direction of velocity changes at every instant. Second, it is a periodic motion, that is particle repeats its path. Kinematics of circular motion. Here, first is angular displacement delta theta is equal to ds delta s upon r. Second, angular velocity omega is equal to d theta upon dt. Third, angular acceleration alpha is equal to d omega by dt. Fourth, at tangential velocity vector v is equal to vector omega cross vector r. Directions of omega, alpha and v given by the right hand thumb rule. Means here velocity direction is in this way and p point is there. This is the radius and this is the angular velocity, that is the omega. Uniform circular motion. Uniform circular motion is defined as the motion of the particle along the circumference of a circle with constant speed. Non-uniform circular motion, it is opposite to uniform circular motion, means if the speed of an object is not constant, then it is called as non-uniform circular motion. The acceleration is responsible for changing the magnitude of velocity is directed along or opposite to the velocity. It is tangential accelerated, that is the AT, means vector AT. That is for example, fan. Means fan speed is not constant. First its speed is low, then its speed will be increased after some time. When you will switch off, then the speed will be decreased. Dynamics of circular motion. First is the centripetal force. The acceleration is responsible for circular motion is the centripetal acceleration. The force providing this acceleration is centripetal force. That is centripetal force is equal to minus m omega square vector r. Second is centrifugal force. That is the centrifugal force is greater than resultant force towards the center. The centripetal force balances the resultant of all the real forces, that is merry-go-round. Then equation is m omega square r. Applications of uniform circular motion. First is the vehicles along a horizontal circular track. For a car moving on a horizontal circular track of radius r, plane of figure is perpendicular to the track. Here you have seen that the diagram is here. Car is there and weight is in downward direction and normal is in upward direction. Here the friction force is there and distance between that is the r. Means force acting on a car, that is first its weight and second is normal reaction, that is the mg, and third is force of static frictions. While working in the frame of references attached to the vehicles, it balances the centrifugal force, that is n equal to mg. This is equation number 1. And second force, that is force of static frictions, and it is m r omega square, that is equal to mv square upon r. It is also called as a centrifugal force. Dividing equation 2 by 1, you will get the equation Fs upon n is equal to r omega square upon g is equal to v square upon rg. And at the speed, a maximum speed, you can see the equation here. Fs upon n is equal to mu s that is equal to V square maximum V max of V square upon RG. Therefore, you will get the equation for V max, that is equal to root of mu S RG. Second is well of date. This is the vertical cylindrical of radius r inside the which a vehicle is driven in horizontal circle. The force acting on the vehicles are first means normal reactions and acting horizontally towards center. Weight mg acting vertically downwards. Force of static friction Fs acting vertically upwards vertical wall and the tires. N equal to mr omega square is equal to mv square upon r and mg equal to fs, means one vehicle is there and that vehicle is moving in a circle cylindrical path. Okay, and on that vehicles three forces are there. Mg is an static friction force is in upward direction and the normal reactions towards the center. These three forces are there. Force of static friction Fs is always less than or equal to mu s n. So you can say that Fs less than mu s n. Therefore, mg equal to mg less than equal to mu s into mv square upon r. Therefore, g equal to less than equal to mu v square r. Therefore, v square greater than equal to rg upon mu s. So, you will get the equation for minimum speed, that is equal to root of rg upon mu s. Third is vehicles on a bank road. Means here vehicle is there and that vehicle is turned in the road at the corner. So at the corner on the road you will get the angle here, that is theta angle. So let r is the radius of the curved road, theta is the angle of banking, and there are two forces acting on the vehicles. That two forces are its weight and second is normal reactions, and it is perpendicular to the surface of the road. As the motion of the vehicles is along a horizontal circle, the resultant force must be horizontal circle and the direction towards the center of the track. First, n result into two components. N first is the n cos theta, that is equal to mg. It balances the weight of the car, that is the mg, and second is the n sin theta. It balances the centripetal force, that is r omega r mr omega square. Here, sorry, centrifugal force is there. Dividing equation 1 by 2 and you will get the equation 2 by 1 and you will get the equation here, that is tan theta equal to v square upon rg. First, most safe speed for particular road r and theta are fixed and that is equal to Vs equal to root of rg tan theta. Second, banking of road, that is equal to here, here diagram is given here in a per direct diagram. One side here, one side force static friction is there and here other side static friction is there, means here theta equal to tan inverse v square upon rg and speed is vs equal to root of rg and the direction of force static friction is for fs between the road and the tires, means at one tires the force is in upward direction, at other tires the force is in downward directions. So the its horizontal components is parallel and opposite to n sin theta. So you will get the equation mg equal to f sin theta plus n cos theta. And second equation you will get mv square upon r is equal to n sin theta minus fs cos theta. Dividing 4 by 3, you will get the equation v1 square upon rg equal to n sin theta minus fs cos theta upon mu s n sin theta plus n cos theta. Putting fs equal to mu s n and dividing by n cos theta, you will get the next equation. That equation is v1 minimum is equal to root of rg tan theta minus mu s upon 1 plus mu tan theta. The directions of forces of static frictions in Fs between the road and the tires is directed along the inclinations of the road to downwards. So its horizontal components is parallel to n sin theta and you will get the equation mg equal to n cos theta minus fs sin theta. So and second equation mv square of mv2 square upon r is equal to n sin theta plus fs cos theta. So you will get the equation v2 max is equal to root of rg tan theta plus mu s upon 1 minus mu s tan theta. This is the equation for maximum speed. Thank you.